This video is provided by Coaching Online iit-jee and delivered by Praveen Kumar Pandey. This is free tutorial videos which helps iit-jee and medical entrance exam aspirant in secure a rank. In all the lecture series we will solve previous year's question of iit-jee and medical entrance exam. We will solve physics, chemistry and mathematics question and explain all the fact related to problems in great depth, and an cutting-edge analysis is provided. Our team upload one video per day. So to get daily update, subscribe our channel. Special thank you to my dad Shri Amrendra Kumar Pandey, G, and my mom Shri Mt Neelam Pandey, G. I dedicate this videos to my younger sister Miss Pratima Pandey. Thank you for tolerating me during making the videos. Without you this is not possible. Thank you.
Welcome to free online coaching. This is Praveen Kumar Pandey, your online tutor. In today's lecture, I will discuss about string. Okay, I will solve question how to illustrate how to solve question in which a string is given. Okay, to you. Till now, I had solved the question in which there is no string, they are connected, and we had seen various type of question. Okay, some of the questions are very difficult. You are not able to understand in first look, but if you try and if you work hard on them, then guys you really able to solve it. Okay, so again guys, in this where I will discuss about the string, here our fundamental step is same. First is to find the first is to find a relation between the accelerations of different bodies if they are more than one bodies, and second is drawing free body diagram. Okay, drawing free body diagram. Okay, so drawing free body diagram, and okay, so before doing some more difficult question, we should consider about this a simple problem, this simple problem, how to solve this question. Okay, because it is going to give you so many things to you. Okay, okay, this access whole copy. Okay, yeah, this mass is m. Okay, this mass is m. It is hanging from this string. Okay, I am right now I am not going to tell how this string is. Okay, it is hanging. This string is massless. Okay, this string is massless. Let me suppose this string is massless. This string is massless. This string is massless. Okay guys, it is hanging from it. Okay, this string is massless and it is hanging from it. Okay, so I am going to draw free body diagram. I am going to draw free body diagram of it. Okay, so here is a mg. Okay guys, here is a mg, here is mg, and it is not coming downward, it is not falling. Okay, here is mg, it is not falling, so there must be a force which hold this mg block. Okay, which hang this mg block and we not allowed to fall it. That force is, let me give it name. Okay, let's give me name. Okay, and there are two things which come in your mind. You can think that yeah, it is a normal force. This is normal force. Yeah, it is normal force because here there is a contact. The string has a mass here, and here is a contact. No guys, this is not normal force. Okay, this is not. If it is a normal force, then it cannot be hang. You got what I'm saying? If this string apply a force which is normal to it, then what should be the free body diagram? It is like this. This is the mg, and this is the f. Okay, it is not like this. If this will happen, then it will fall. Okay, so this force string is not applying normal force. The first thing is, if you can think na, you can think like here is a contact. If there is a contact, there must be a normal force. But here there is not normal force. String is not applying normal force. It's doing something another thing. Okay, some different thing. It is doing on this mg. Okay, and it is not allowed to fall down. If it is not falling down, then this must be situation like this. Okay, this must be situation like this. This is the force. This is the force. Who had applied this force? String had applied. Who had applied this force? String has applied. Okay, guys, who has applied this force? People call it T for tension. Okay, people call it T for tension. Okay, so one thing you should know, you should realize that string does not apply a normal force. Okay, if it apply normal force, then this is not possible. Okay, you may think that, yeah buddy, look here, there is a contact between it, and then there should be a normal force because this is the contact between string and spring. Here it is a surface, but it is not like that. String does not apply normal force. Okay, if apply normal force, then it will be situation like this. You may ask why, how, why not, but yeah, it is. Okay, it is. So okay, so you should consider, you should look that how this uh, string will apply a force on this mg. Okay, okay, now I'm going to draw the free body diagram of this string. I'm going to draw the free body diagram of this string. Okay, guys, so this is the string. Let me suppose this is the string. I had just okay, okay, let's cut this. Let me draw the vertical string now, so that you, this is the string. Okay, this is the string, and here what is the tension? Okay, listen, who has applied this force? Who has applied this force? Who has applied this force? Who had applied T force on mg? String has applied. So this block of mass mkg will apply force on string. Yeah, of course. How we know? By Newton's third law. Okay, let me write down what I have said. Who had, question is, who had applied this force? Who had applied this force? Okay, guys, who had applied this force? This answer is string. So will this mg, this block of mass mkg will apply force on empty string? Yeah, of course. By how much amount? T. In which direction? Opposite to it. Okay, by Newton third law. Okay, this is here I should write here Newton third law. Newton third law. Okay, guys, here I should write Newton third law. Okay, here again, if you know, here is a force, which is T, but each string has acceleration. It is string is moving. Answer is not. So to balance this force, this T, there must be a force which could balance it. So here there must be a force. Here there must be a force. What should be the amount of this force? T. Okay, again guys, here you know, look at this contact. You may think, yeah, here should be a normal reaction, but if here should be normal reaction, so how should be the action of force by string? This. Okay, okay, you got what I'm saying? If this support apply a normal reaction, this support apply a normal reaction on this string, what should be the action of force, by this support on string? This should be, no, this should be direction. Okay, you should think, just forget to, if you want to understand what I'm trying to say, just forget about tension and just think about normal reaction. Just think about normal x. You know guys, if this string apply normal force, then it is not possible to hang this. Okay, a normal force, if you draw the favor diagram for normal force, the situation will be like this. This is the mg, this is the normal force. Okay, so what I'm trying to say, that string is a special type of force. What I'm trying to say, string force by a string is a special type of force. Okay, it's act in a different manner. Okay guys, so here this is the string, this is the string, here this is the tension, and this is the tension. Okay, if this amount is t, this must be t, because there is no acceleration, because there is no acceleration. Okay guys, okay, so let me draw the free body diagram of support. Let me show the force applied by string on support, on this support. Force applied, let me say force apply, okay, yeah, force apply, yeah, let me write down here, by string on support, okay guys, force applied by string on support. So if I draw the free body diagram of this, then this is my support. Okay, and what is the direction of force applied by support on the string? This. What should be direction of force applied by support on a string? This. So what should be direction of force applied by string on support? Let me write down. If I write down, then it becomes clear. Okay, what is direction, of force applied by string, applied by support. Okay, support on string. You should ask this question by yourself if you want to learn things. Okay, if you are not going to ask the question by yourself, then it becomes slightly difficult for you. Okay guys, so what is direction of force applied by support on a string? Okay, so look here, this is direction, no? It is too simple. This is t here, and this is the t. Who has applied this t? This support has applied. Okay guys, who has applied this t? This support, Mr. Support has applied. Okay, who has applied this t? Mr. Support has applied. Okay, so it is, I think it is clear, and you should ask this question by yourself when you will learn. Okay, who has applied this force? This support has applied. Okay, will string apply force on support? Of course. Why? By Newton's third law. This is my support, and this is the force. This is the force by support on a string. So string also apply force on this support and this direction. Okay guys, again here if you think it just like normal reaction, then it will just opposite to it. Okay, so you should just be careful. What should be direction when string come in picture? You cannot think in normal reaction term. Okay, you should be careful whenever string come into the picture. Okay, whenever string come into the picture, you should be careful. You cannot think in normal reaction manner. Okay, and another important thing about string is, the forces on string try to keep it tight. What I'm trying to say, the forces on string trying to keep it tight. Okay guys, forces on string trying to keep it tight. For example, this cannot be force on string. If this force on string in this manner, then string will be loose. String will be loose. It cannot be tight. Okay, if apply force on string in this manner like this and this compress this manner, then it will not be tight. Okay guys, and second thing is, you may think this manner, that this there should be a force in this direction and another force should be in this direction. Again guys, in this situation it may possible that the string is tight, but this point has different acceleration, this has different acceleration. Okay, and it is a complicated thing. It is not happen, you will not see situation like this. Okay, so it is correct or not correct, we are not going to discuss about it. Okay, you may think that the string may be tight in this manner, because if this point is moving very fastly and this is not fastly, you may think. But one of the very important thing is that one of the very important thing is that this string should be tight. This string should be tight. Okay, whatever situation is, and this situation is not, and this situation is not going to happen. Okay, string cannot increase. String is inextensible. Okay, inextensible. Okay, so there are so many things which come in your mind, like yeah, it may forces it is possible to keep force on this manner. It is possible on string to force for free body diagram of string in this manner. Guys, it is not going to happen. Okay, because string should be tight, and only one possible which you learn in your which you see in your daily life, in your questions, which is this. Okay, so don't think that this should be in this manner, this should be in this manner. And if you have enough time, if you are wanting to understand by yourself, do it just for fun. Okay, and see and explore all the other possibility. You may think in better than me. Okay, so this is not possible, this is not possible, only this type of process is possible on string. Okay, and another important thing is, on string we cannot apply compressive force. We cannot apply the force direction of force on string is always away from it. What I'm saying, look, the force on string at each point should just keep it tight. Okay, so at this point is the force try to keep it tight. This at this point the string force on string should try to keep it tight. Okay, the force on string is always try to keep it tight. Here this is not going to happen. Here this force try to keep this string loose, and this try to string tight. Okay, so you may think in this manner, you may think in this manner, you may think in this manner, and it is, and this is useful. This type of thinking is useful. Okay, first, string should be tight, and the force on string at every end, force on string at every end, try to keep it tight. Okay, for example, this is a string. Okay, let me write down here and draw here. Okay, if this is a string, then force at this point will try to keep it tight. How should I apply the force to keep it tight? No, if I apply the force in this manner, it will compress. Okay, I should apply the force in this manner to keep it tight. At this point I should apply the force to keep it tight. If I apply this manner, then this string will not be tight. Okay, I have to apply the force in along this. Okay, so force on a string always try to keep it tight. Okay, So force on string, always try to keep it tight. The force on string, always try to keep it tight. Okay. Okay. So let's come to the question. Here, to one thing which is very important, this line is this statement: the force on string always keep to try to keep it tight. Okay, guys, this is the very important line. This is the very important statement. Okay, so let's come to the question. Okay, this is the string. This is the string. This force is T. Okay, this force is T. Yeah, I see string, I had applied the force. Okay, I see this string, I had applied the force. This, because I know whatever happen at this in this string should be tight. So this is the force. Okay, and here this is the mg. This is the mg, and who has applied this force? This block m has applied this force. So this would be like this. Okay, guys. Okay, and second thing is this is the end. This is the end. So this is my end of my string, and how the support will apply the force on it to keep it tight. So this will be the T. Okay, so this will be a force. Let me suppose this is T1, this is T2. Let me write it. It possible that this force is something another, this force is something other, to keep it tight. So here is a force T1, here is a T2. Okay, so just think that string should be tight. How it will tight? If we apply force in this manner. Okay, if we apply force on string in this manner. Okay, so guys, is there any acceleration of mg? No, it is in a stationary state. So T should be equal to mg. T should be equal to mg. Okay, is there any acceleration of this guy, this string? No, so T1 should be equal to T2. Okay, here, and the support, so we are not going to solve support because it has huge mass, and okay, it has huge mass. So what is the acceleration? Its acceleration will be 0, because by very large mass, that will be 0. Okay. Okay, guys, now let's solve some another question. Let's see some another question on string. Okay, let's some simple question. Let's try how to solve the question of string. Okay, this is a ground. Okay, this is ground. On this ground, here is a mass. Let's suppose this mass is 1 kg. Okay, this mass is 1 kg, and it is attached here. This is the string between it. Okay, here is string between it. Okay, so here is string, and this mass, let me suppose this mass is 1 kg, and here I had applied a force of 2 Newton. I had applied a force of 2 Newton. Somehow I had applied a force of 2 Newton. Okay, and let this string is massless. What is the string? Massless. Okay, this string is massless. This means its mass is 0. Okay, find first question. Find pala acceleration, acceleration, find acceleration, find acceleration of, let me give it name block A, and this is block B. Find acceleration of block A. Okay, so block A, first question. Second question is find acceleration, find acceleration of block B, acceleration of block B. Okay, find acceleration of block B. Okay guys, so all of these are very simple and you can okay. So first thing is I should, and another extra thing is given in this question is that string is inextensible. This means we cannot increase length of the string. Okay, string is inextensible. This means length of string cannot change. Okay, string cannot change. This is the one of the most important line in solving the question of a string. Okay guys, okay, so we should do, what is our fundamental step is, first we can draw the free body diagram, okay, and then we have to find out acceleration relation, okay, acceleration relation. We have to think about it, how acceleration of different bodies is related. And third is writing equation. Our third step is writing equation. Okay, now you can exchange in first and second. You can first draw the free body diagram and then you should try to find out the acceleration. Either you can try to find out acceleration first and then draw the free body diagram. Guys, I will prefer this first, okay, because I want to grab your total attention in finding how acceleration is related, how to find out acceleration of connected bodies. Okay, again here look, this body is connected by a string. Okay, in my previous lecture you will see all the questions in which body are directly connected. Here it is not going to happen. Here they are connected by string. Guys, in some question this situation maybe will like this. Here is your mass, here is your mass m1, okay, and here they connected by spring. This is the m2. Here look, here they are connected by spring. Okay, so we will learn one by one about everything. What happen if they are directly connected, what happen if they are connected by string, and what happen if they are connected by string. Here what happen, how to solve if they are connected by string, how to solve if they are connected by spring. Okay guys, so you should think in this manner how the body is connected. Listen, here the connection with string is totally different, because this just opposite. You look the free body diagram here. Okay, look free body diagram here. Okay, so it just change the situation. You should think in this manner. Okay guys, hope I wanted to give you advice. Guys, you cannot see this lecture by listening. You cannot learn by physics by seeing the lecture. You have to grab your copy and pen and write down the equations and write down the things. Try to find out the things by yourself. Okay, we are here to just help you in this process. Okay, listening the lecture and reading a book of physics is a necessary step, okay, is a essential step to learn physics, but it is not sufficient. Okay, you have to solve the question, you have to think in this manner, how to encounter this problem. Okay, and to it you have to work very hard. Okay, and it's depend upon you how you love these topics. Okay, and it is very interesting to solve these questions. Okay, this is 1 kg, this is 1 kg, and this mass is, okay, this mass of the system is massless. Okay, so I should first, what I do, I will try to find out acceleration relationship. I try to find out what should be the acceleration relationship. Okay guys, okay, we will try to find out what should be the acceleration relationship. Okay, and what is the most important thing is length of string cannot change. Okay, it will fixed. Length of string cannot change. So let me try. So this is, let me draw the figure diagram for block A. Okay, this is block A. Okay, and if I draw the figure diagram piston, it will be better. Okay, it will be better. So let me draw the figure diagram of piston. This string is massless. Okay, it may possible that tensor at this point will be different, and what will be, we don't know. We will try to find out. Okay, so here, at this point string should be tight, so string force should be in this manner. Okay, this is T. Okay, at this point again string should be tight, so force on string will be this manner, and this is TB. Okay, this should be the force. This should be force on string. Okay. We had draw the figure diagram of string. Now I should consider about, I am going to draw the figure diagram of block A. So this is F. Okay, this is 2 Newton. This is 2 Newton. Someone has applied 2 Newton force, and how they had applied is not our uh, okay topic. Who had applied, how had applied, okay, it's another thing, but somehow 2 Newton had applied. Okay, listen, see here, who has applied this tension, who has applied this force TA, this A has applied. Will string also apply force on this A? Yes, of course. So it will be in this manner. Who has applied this force? This will be TA. If this is a TA, this will be TA. How? Okay guys, again, and I'm going to draw the figure diagram of this. I'm going to draw figure diagram of this. Okay, this is B. Who has applied this tension? This B has applied. Who has applied this force? B has applied. So string will apply force on B. How? By Newton third law. This is B. This is TB. Okay guys, so let think me acceleration. Okay, let's try to find acceleration relationship. Okay, one of the important thing is that this length of this is not going to change. Okay, it is slightly first time, so that had I'm going to do it, but okay, it's just okay. From onward I will do it this first, and then actually this is the freeboard diagram. So, and I am teaching string first time. If you are in just intern in class 11th, then most probably it is possible that you are learning by me online. Okay, So this is ta, this is t. Okay, so let me draw the free word. Let me think about acceleration. And the method of finding acceleration is same as in previous class. Okay, we will use geometry. What we will use? We will use geometry. Okay, let's, this length is L. This length is here to here is, okay guys. So till now what I had said that we, by using geometry, we will find the we'll try to find relationship between acceleration of different bodies. Okay guys, so this is my B, this is my B, and here this is the string. Okay, and this is my block A. Okay, my block A. So here I had apply a force F. I had apply a force F. Okay guys, so no, you know, let's see what will happen. What if I apply force, then this will move, this point will move by distance x. Let me suppose this point will move by distance x. Okay, this distance is x, and reached somewhere, this point reached somewhere here. This length is, this length is x. Okay, this length is x. Okay, so this, let's suppose this travel by amount, this has traveled by amount x, this has traveled by amount x. Okay guys, so you know, this point has, this point has also reached here, this point also reached here. Okay, and again let's suppose this travel by amount y, this travel by amount y. Okay, this travel by amount y. Okay, so you know, if this travel by, if this travel by amount y, so this point also reached here. Okay, this point also reached here. Okay, now we wanted to try to find out what should be the relation between, x and y. Okay, you know guys, it is given that length of string is constant. Length of string is constant. Okay, length of string is constant. Okay, length of string is constant. So what happened to it, and this is, okay, so you know, initial length, this and this will be L. Okay, this will be L. So, and new length is, this is the new length, this length, let me draw it upward so that you can see it clearly. This length, this will be the new length. Okay, this also should be L, because length is not going to change. Okay, so what is this length? If you see it carefully, you know, this length is this L is this length, this L is this length. Let me suppose this length which is Z, and plus this. Okay, and plus this amount. Okay, and this amount is x, so we have to find what is this length. If you see carefully, this is L, this is Y, so this will be L minus Y. Okay, do it by yourself. This Z will be L minus Y, and this is x. So new length is Z plus x, and Z is equal to L minus Y. So what should be L minus Y plus x? This should be equal to L. So what is the L? L to L cancel. I get Y is equal to x. Okay guys. So here I find out what is the relation between x and y. So here d2y divided by dt2, this should be equal to d2x divided by dt2. Okay, it is very simple. d2y by divided by dt2, this should be equal to d2x divided by dt2. Okay, it is very simple. So I had done it. It is very simple. Okay, okay, okay. So you know what is the this y? This means d2y. Who had travel y? B. This means acceleration of b should be equal to acceleration of a. Acceleration of y should be equal to acceleration of a. Okay. So it is very simple. Now I should write down the equation. I should write down the equation of motion. Okay. At first instant, I had draw the freeboard diagram. You can see it here how I had draw the freeboard diagram, etc. Then then I had try to find out this relation. Acceleration of A should be equal to acceleration of B. Okay. Now I should try to find out uh, forces. Okay, tension, force, etc. Okay, okay, friend. So let me write down the equation of motion, equation of forces on for A. Here this is the 1 kg. This is 1 kg, and here this is 2 Newton force. Here is the tension. Let me. This is TA. Okay, friend. This is TA. So what can I write? Let's suppose it has traveled in this direction. Okay. So I should take this direction as my principal axis for convention, because you should, if you do not want to use conventional method, do it by yourself. Okay. But I will use this. So this is the my direction of x-axis or direction of motion. So I should take this as my principal axis. So this is my positive direction. This direction is my positive. So 2, and this is positive. This is opposite to this. 2 minus TA. This should be equal to mass 1 kg and acceleration A. Okay, acceleration of A. Okay. Now here. Now again look, now I am going to write down equation for string. I am going to write down equation for string. Okay, this is TA and this is TB. Okay, okay guys, this point, acceleration of this point is T, acceleration of this point is A, and acceleration of this point is AB. Okay, and both are equal. So at string acceleration each point, this point is also A. It is very important. Acceleration at this point is A, acceleration at this point will be A. Okay, these things you should realize it. Okay, I will explain you in later classes. Okay, when I teach you systems and another center of mass, etc., I will explain you what it means. Okay, for the time being, for this time, you should know that what will be acceleration at this point A, what is the acceleration of this point A, what is the acceleration of this point A. Why? Question arise why. Okay, why means how I know it. How I know it. There is any mathematical proof. Any mathematical proof. Okay, there is any mathematical proof. The question is yes. And this is your homework. Okay, you should do it. You should try to find why acceleration this point should be same. Okay, this is your homework. You should do it by yourself. Acceleration on this point is A, acceleration on this point is A, acceleration on this point is A, acceleration on this point. All the point has same acceleration. Why? Hint. I am going to give you hint. String is inextensible. Okay, inextensible. String is inextensible. Okay, so accession of this point, each point is a, accession of each point of a string will be same. So should I write ta minus tb, and direction is in this direction? This should be equal to m into a, accession of a. Okay, okay. And again, here is the important thing. What is the mass of this string? What is mass of this string? Mass of this string is 0. What is the mass of this string? 0. So whatever accession of this string will be, this quantity always be 0. Always 0. Why this will be 0? Because mass is 0. So Ta is equal to Tb. This means in a string, tension at each point will be same. What will be tension at this point? Same. What is the tension at this point? T. What is the tension at this point? T. What is the tension at this point? T. Why? Because it has 0 mass. It has 0 mass. If mass is 0, then tension will be same. Okay. I will solve you some more questions so that you could grab this concept. Okay, but we will do it in this manner, in this way. Okay, this is the first question, so it looks something weird to you, and it's normal to look weird. Okay, this is the first question. Okay, so it's okay to look weird. If you frustrate with this, it's okay, it's normal, it happened to people. Okay, so Ta minus Tb, this is 0, and why this 0? Because mass is 0. Whatever accession is, this always 0. Okay, so Ta is equal to Tb. Now I am going to write down equation for B. Okay, this is B, and here there is only one force. This is Tb. So should I write Tb is equal to 1 mass of B and accession of B will be A. Accession of B will be accession of A. Okay guys, accession of mass will be accession of A. So Ta is equal to accession of Tb is equal to X, and T is equal to Tb. So Ta is equal to 1 into accession of A again, and here 2 minus Ta also 1 into accession of A. Okay, accession of A, add these two, what I get? 2 is equal to 2A, accession of A. The accession of A is equal to 1 meter per second square. Accession of A is equal to 1 meter per second square. Acceleration of B is equal to also 1 meter per second square. Now what is the tension? It is very simple to calculate tension. Ta is equal to 1 into 1, so tension is equal to 1 Newton. Okay, so guys, do it by yourself. Okay, and this is for today lecture. In next lecture we will solve some another aspect and of string, and learn how to encounter problem in which you find string. Okay, involving the string. All of these things are very simple to calculate, and if you work hard, if you try to understand the things, then you will easily able to do. Okay, and these are as there are some fundamental things. For example, this string is massless. Okay, string is inextensible. These lines, these things are very important to solve the question easily. Okay, so work on it, try to understand these things, you will able to do it. Okay guys, see you in next class. Thanks.
Hey buddy, hope you understand whatever I am explaining to you. So work hard and enjoy the life. If you want to see me tomorrow, then subscribe my channel, because viewers like you support and motivate us to make videos. Please share this by clicking on the share button on Facebook, Twitter, Instagram, and other social networking sites, so that a needy one get benefit and spread about it among your friends. My dear students, an important message for all of you. We are trying to take an online exam, which will be totally free for trial period, means till July 2017. If you are interested in it, then you can register by sending an email or a message on WhatsApp. My WhatsApp number is 700 7719110 or by giving them a call on 775-896-205. We will give more detail about it in our forthcoming videos. Thank you so much.